centered on 660.
13th of August 1989. 10 years after the decision to build and 20 million working hours later, the Large Electron Positron Collider, LEP, was ready to start. With its almost 27 kilometre circumference, 100 metres below ground, the Lord of the Collider Rings, as it was dubbed, was the largest scientific instrument ever built and its tunnel Europe's largest civil engineering project. Designed to push the frontiers of knowledge through high precision measurements of the recently discovered Z and W bosons, this pioneering machine consisted of a string of 5,176 magnets and 128 cavities to accelerate electrons and their antimatter counterparts and guide them into collision at close to the speed of light. A small suspended train ferried pieces of equipment around the ring, a veritable subway, with underground caverns 8 stories high to house 4 enormous detectors. All 4 detectors were about 10 metres in each direction, weighing up to 1,000 medium-sized cars. Layers of sub-detectors picked up and identified the particles produced in collisions. The resources needed to build and operate them required large collaborations coming from the European member states of CERN, but also Asia, Israel, Russia, and the US. In spite of being competitors, they collaborated to combine all experimental data in order to get the most precise answers. LEP was located below the bucolic village of Echinetics on French territory inside LEP's deepest caverns and had at its core a time projection chamber, for years the world's largest. At point 8 lay Delphi. Its superconducting magnet was, at the time, the largest ever built. L3, the acronym simply meant letter of intent number 3, boasted what was then the most powerful magnet in the world, generating a field 10,000 times stronger than the average field on the Earth's surface, and was made of 8,500 tons of iron. It is now still in place as part of the ALICE detector in the LHC in the same cavern. Opal was installed at point 6 of the LEP ring in the commune of Versenix, right next to the Swiss border. Its design was based on well-tested technology to guarantee reliability of its performance. Opal recorded the first Z boson of the LEP era. Digging a tunnel 100 metres underground with millimetric precision through rock and river was a major feat of engineering. On the 8th of February 1988, the two ends of the 27-kilometre ring came together with just 1 centimetre of error. The first beam circulated on the 14th of July 1989. Collisions at 90 GeV came 1 month later on the 13th of August, during the accelerator's 5-day pilot run. Just 5 years and 11 months after the groundbreaking ceremony, the quest was on.
C'est parti.
On the 13th of October, the 4 collaborations presented their first results at CERN. It had taken them only a few weeks to answer one pressing physics question. What was the number of light neutrinos? The unanimous answer was 3. Such an important measurement of nature's deep properties meant that the number of families of quarks and leptons, the fundamental bricks of the universe, is just 3. The entire chemical composition of our universe depends on this number. After such a triumph, LEP was officially inaugurated on the 13th of November 1989 in the presence of heads of states and ministers from all of CERN's 14 member states.
De participer à cet événement qui marque le début du fonctionnement du plus grand instrument scientifique au monde.
The years 1990 to 1995 were devoted to high statistics, high precision running, operating at 100 GeV. LEP produced 17 million Z particles, 2 orders of magnitude higher than any previous accelerator. It was so precise that the energy of its beams was unexpectedly affected by the moon tides, the amount of water in Lake Geneva, and the passage of the French fast train TGV. LEP was then upgraded for a second operation phase with 288 superconducting accelerating cavities, doubling its energy. At the 1994 winter conferences, the 4 experiments presented a combined measurement of the Z with a precision of 3 MeV, which was the main ingredient to calculate the top quark mass. Only a month later, the first observation of the top quark was announced at the Positron and Fermilab Chicago, with the mass predicted by LEP. The long hunt to the Higgs boson was among the objectives. The boson's mass wasn't predicted by theory. The 4 LEP experiments explored it in a range up to 115 GeV, providing clear hints that it should not be too far. It was in fact just 11 GeV short of the value discovered by the ATLAS and CMS experiments at the LHC 12 years later. LEP was closed down on the 2nd of November 2000 when it had reached its maximum energy of 209 GeV to make way for the construction of the LHC in the same tunnel. Beyond the tremendous physics importance, LEP marked a turning point in the history of CERN. Unprecedented in size and geographical range, the LEP experiments triggered the invention of the World Wide Web and set the mould for the globalization of particle physics, ushering the LHC era.